Okay, the next speaker will be Mr. Srinath Himanshu from China Solar. Mr. Srinath joined China Solar in 2018 as Business Development Manager and currently looks after module and system solutions business in Bangladesh. Srinath has been working in solar industry for 12 years as a renewable energy enthusiast. His experience is evolving from design engineering, project management, investment community to business development. With his expertise in technical and commercial fields, he helps stakeholders and customers make right decisions in selecting suitable solar solutions. And he has a bachelor's degree in energy engineering from India Institute of Technology, Karampur. Now let's welcome.
Thank you, Claire, for the introduction. Good afternoon, everyone. In this session today, I would try to cover about Trina Solar and the products and offerings that we have for Bangladesh. So let me start the presentation. I hope you can all see the screen, right?
Yes. Okay. It's clear.
So let's get started with Trina Solar, the history. So Trina Solar, we were founded in the year 1997. And it's been a journey, a remarkable journey of 25 years since then. So we proudly claim that as Trina Solar, we are one of the oldest and the most reputed company in the industry, which has got sustainable business for 25 years so far. So in this time frame, I mean, in this the milestones that we have, so we can very clearly divide it into three different areas. So we started as an EPC, in which we used to do small solar EPC solutions. Like in the year 2002, you can see we did our first 40 off-grid solar power stations in Tibet, which are still operational. And we as Trina Solar, we are providing the service support, and these systems are still functional with all our efforts. Moving forward, in the year 2006, this was another major milestone for us. This was the year when we got ourselves listed in New York Stock Exchange, and then from here we started to grow like in leaps and bounds. So in the year 2008, we established our fully integrated Trina Solar PV industry park. And I must highlight here that, I mean, this journey of 25 years, it was not just a matter of coincidence. I mean, it was all calculated and a right philosophy with inclusive growth as the base that we have come so far. I mean, all this philosophy, it has helped us to have this sustainable business. And with that idea, I mean, we were among the first one to develop the ecosystem. I mean, like prior to 2008, most of the manufacturing, they used to have their standalone system. But our management back then, we realized that the standalone businesses, they are not sustainable. So we were the first one to establish a fully integrated setup in which we developed an industrial park, which was spread over 14 square kilometer, in which we developed the entire ecosystem, right from a supply of glasses and everything in the near vicinity. So I mean, like industry, we started as panel manufacturing, and we co-developed the ecosystem with ancillaries and everyone to have a common goal to have like best quality product. Or prior to this, I mean, the situation used to be like for any quality assurance, the people had to travel to different locations to ensure that the quality of the product is good and all. So with this, I mean, industrial park, we could ensure that everything is in single location, and we deliver a product which will have a life of 25 years. Moving forward, in the year 2012, we established our own state key laboratory of PV science and technology, because back then there were very limited resources available for testing, and there were very limited even protocols for testing different attributes, different characteristics of the solar panels. So we took the initiative, we developed protocols, not just protocol, but a lab which was qualified by UL. That, I mean, any test that we do in our lab was as good as it was done in any third party. Before we launch any product, we will pass it through like 200 stringent test conditions in our state key laboratory of PV Science and Technology. So the product and the quality that you get as an end customer, that will be reliable and that will have performance for 25 years. Moving forward, in the third era, so we established ourselves as an energy company. So rather than being just an OEM of solar PV manufacturing, we diversified our business into bigger portfolio. Like we acquired a Spanish tracker company and we introduced a tracker product in our portfolio. And beside this, we established ourselves as an EPC company and a system solution provider as well. So depending upon the requirement of the market and different reasons, so we have different products and offerings to cater to the specific requirement of different markets. Then beside this, we expanded our capacity outside China as well. In the year 2016, we established our manufacturing setup in Thailand and later in Vietnam as well. Our next major milestone was in the year 2020 when we got ourselves enlisted in Shanghai Stock Exchange. And with our reputation and our brand name, our IPO was received with an overwhelming response, and we gained more than 100% on day one itself. And this gave us a huge impetus. And then from a manufacturing of 9 gigawatt in the year 2019 December, we expanded our capacity. And as we speak today, we have a manufacturing capacity of 50 gigawatt in solar panel manufacturing and 40 gigawatt in cell manufacturing. Later in the year 2021, we established, we adopted a major technology change in our product, which was basically from the traditional, the conventional cells. We have upgraded all our product to the latest available cell, or you can say the wafer technology of 210 mm. We call it as a Vertex series. So now all our products are available with this 210 mm wafer, which is the largest format of cells and wafer that can be handled and can be utilized, which I'll explain in more detail in the subsequent slides, like why we shifted to 210 and all. So that was a major technology adoption that we did in the 2021, and we upgraded all our machineries and everything to cater to this wafer size. In terms of our global presence, we are based out of China. We have our headquarters in Changzhou. That's where we have established our first integrated manufacturing unit, as I was trying to explain in the previous slide. Beside this, we have other manufacturing unit as well in China, which is in Yibo, Suqiang, and Yancheng. So all this capacity together, we have the manufacturing capability of 50 gigawatt as of now. The entire global operations we have divided into 7 different zones, and each different zone, they have got their own regional headquarters. So like for Asia Pacific, we have a regional headquarters in Singapore. So from Singapore office, we take care of business and operations of for all the countries in Asia Pacific, including Australia, Bangladesh, Nepal, Sri Lanka, Pakistan, and India. And beside this, depending upon the requirement and the call of the market, we have a regional presence as well. So like we have regional offices in different locations, and the one which is near to the Bangladesh is India, which is one of the largest the market in Asia Pacific. So from India office, we take care of business and operations of India, obviously, and then Nepal, Sri Lanka, and Bangladesh. In terms of our global segment, we have already achieved the benchmark of 100 gigawatts so far. So that's the cumulative capacity since our inception that we have supplied globally our panel. And beside this, as an EPC, like in which we provide a turnkey solution, we have commissioned 5.5 gigawatt of our own project, which are already connected to the grid, up and running. And we have our products and services available for more than 100 countries as of now, and we are steadily expanding. I mean, anywhere, any place where we are not now. So we are expanding, and we are supplying. We are trying to supply our products and services in those countries as well. So this slide, it's an important slide because I think, I mean, in solar industry, there had been certain incidences in which like the companies who were once at the highest position, they could not sustain the business. So I mean, before telling more about this thing, let me introduce Bloomberg first. I mean, why this concept of Bloomberg NEF, which is Energy Federation. I mean, they are an agency which is one of the most reliable agency in the solar industry, or rather I can say in the renewable industry, in which they do the ratings, rating, and they qualify different manufacturers, different developers in all categories, and they prepare their own list and checklists. They have the parameters against which they make a judgment like which company is more reliable than others. So this concept started in the year 2014, because back then in these years there used to be, like as I mentioned, the largest companies who were the like I mean one with the largest shipment, they used to file bankruptcy the very next year. So there was a common fear factor in the market that whom to trust. So Bloomberg in the year 2014 came with this philosophy in which they started to evaluate the manufacturers based on their technology, based on their pipeline, their financial stability, and they prepared their own list. Initially, they came with the tier 1, and later they introduced the bankability as well. So bankability basically means like as a brand, a company, how reliable it is to get financing from the banks or from the creditors. So based on these parameters, they prepare a list, and we as Trina Solar, from the inception of this bankability and this study, we have always featured among the top position, and in last 6 years we have led the pack. I mean, we have been on the top position 6 times in the row from 2016 till date. So Trina Solar as a brand, we are one of the most trusted, most bankable brand in the solar industry. And that's for the obvious reason that we are the only one with 25 years of history in manufacturing as well. In Asia Pacific region, we have a strong presence. Since 2017, in this 4 year, we have supplied more than 13 gigawatt, and we are among the top 3. And the nearest market to the Bangladesh, which is India. So we have very strong presence in India with 12% of market share. So we have installed capacity of more than 7 gigawatt in India as of now. And with that, we share like 12% of the overall market share. Trina, this CNI solution is basically a custom-made solution for Bangladesh market. So I mean, I mean, this is an important slide for viewers from Bangladesh, because I mean, while talking to many customers in Bangladesh during my visit, as well as over call, I got to learn that there were few projects in Bangladesh which were done like a couple of years back or 3 years back, and customers are not happy with the performance of the solar plant. And in most of the cases, I observed that primarily the issues were either because of a wrong choice of technology, product, or maybe the poor workmanship. So we did some exercise on this, and we came up with this solution in which, other than just supplying panels, we as Trina Solar, we have come up with a bundle solution in which other than supplying component, we supply services, as in terms of procurement, engineering, and project management services as well. So what we do here is, other than the traditional PV manufacturers who are just supplying their brand, their product, and maybe some other components, so we come up with our full-fledged engineering team based out of Singapore. So they do hand-holding of the EPC companies in bringing them up to the global standards. And beside this, we help them in procurement support also. So like Bangladesh, since it's a new market, and the industry, the ecosystem is still catching up. So most of the component people are sourcing from overseas, which is primarily from China. You talk about inverters, structures, even DC cables, and all such components. It's being sourced from China. So we, as a service provider, instead of we help you to club everything together, and we would ship everything under single BL, under single LC. So so with this offer, you have two major advantages. The first is like you save significantly in your logistic cost. So if you source every component separately from the OEM directly, you have to pay separately for the logistic cost. And looking at the current high sea freight and all, the logistic cost plays a very significant role in your project landed cost. So with our bundle solution, we club everything and we optimize the space in such a way that you can utilize and you can reduce the number of containers or number of boxes that you need to ship everything from China to Bangladesh. So you first of all save significantly in your sea freight. And then in Bangladesh, there is a limitation that for international transactions, you cannot do a DT or wire transfer. So all transactions, it is done through LC. So like if you do multiple transactions for different OEM, it becomes a bit difficult for you to handle all such banking transactions, LCs and all. So if it is a bundle solution, so Trina would be your one-stop solution in which you would be opening one single LC to Trina Solar and we will take care of the rest. And beside this, I mean, other than this, since we'll be your one point of contact, so for any service need also during the service life of the product, so your single point of contact is Trina Solar, and we will make sure that with our relationship with the OEM, I mean, your service requests are addressed on time, and you get better service than what you would be getting otherwise with your direct relationship with the OEM. So this is second advantage. And third, obviously, is, I mean, you save significantly in your manpower cost and everything. So this is one particular solution which is available for Bangladesh market. And yes, I mean, for the upcoming EPCs, we do proper hand holding in their engineering as well as in the project management support. So and we are doing good business under this Trina CNI solution, and we are helping, like, I mean, the end customer and the EPC companies to have a good experience with their solar power plant. Now, coming to our panel technology. So as I've explained in my first slide, so we have migrated to a major technology change, which is like we are moving ahead with the largest possible wafer size, which the market, which the semiconductor industry can offer now, which is 210 wafer or cell size. So the salient feature of our this Vertex series is we have got multi-bus bar. So in all our panels, we have got 12 bus bars, and we are using innovative cutting technology, which is non-destructive laser cutting, in which the longevity and the lifetime of the cells are much higher. The mechanical strength and the longevity of the cells are much higher as compared to the conventional cutting technology. And obviously is the high density packing. So I mean, in order to improve the efficiency at the panel level from the cell, it is very important that you have a very good packing density when you are integrating the cells in a panel. So with our skill, with our experience of 25 years, we have mastered the high density packing, in which we get a very high conversion efficiency at module level as well. Beside this, we are already ready with N-type TOPCon product, and for some markets, we have already started commercially selling this product. But this being a premium product, I mean, we are just waiting for market to ready to adopt to accept this product, and we are all geared up. And once there is market acceptance, we can very easily ramp up our production, and we can start supplying this N-TOPCon as a mass product. Beside this, we have another technology, which is heterojunction, which is already a ready product with us now. However, this is something which is at pilot stage. So we are doing some projects. We are evaluating the performance and the market acceptance of this product, the HAT, and we believe that very soon, maybe in a matter of maybe 2 or 3 quarters, this technology would be the obvious choice of the customers, and accordingly we would scale up our production, and we would gradually shift from the P-type and type to HAT technology. So this slide basically is like the evolution of solar technology, and you can say the power bin and the cell size. So you can see on the right hand side, there is a graph, like in last 10 years, the technology and the power beam, there was not very significant change. So where we started from 300 watt peak panel, so in last 10 years the technology only shifted to 450 and 400 watt peak panels. But what you would observe in last 1.5 years time, the technology shifted very significantly. So from a wafer size of 158 mm, we gradually shift 156 mm rather, we gradually shifted to 158, 166, and then there was a call whether we would like to shift to 182 mm wafer or cell size to straight away 210, which the semiconductor industry has the largest size of the cell which they can offer. So I mean, based on this trend, wherein we are seeing that the demand from the industry, from the customers, it has significantly increased on the high power output. So you can see on the left hand side from in the year 2020, the demand of high power output was 41 gigawatt, while in the 2021 the high power output panel demand increased to 85, and in 2022 we expect this demand to go as high as 129. So obviously, with the limitation of 182 mm wafer size, wherein we have a limitation that we could maximum produce 545 or 550 watt peak panel, we straight away jumped to 210 mm wafer. We upgraded all our machineries, and wherein we have flexibility that we can produce as high as 670 and even 700 watt peak panels also in very recent times. So 670 we are already ready now. I mean, 670 is already our mainstream product, and that's our flagship product which we have commercially launched, and which we are promoting aggressively among all our customers. And very soon this 700 also would be our main product, and market will have acceptance for this product as well with our 210 mm wafer size. So as I was telling that, I mean, while we Trina Solar, we are the pioneer on different front, be it like technology, the upgradation of machineries, shifting of the wafers from small size, small format to the larger one, 210. But we make sure that we develop the ecosystem around it. So we do not want to stand alone, grow and not stitch up the downstream business. So with our large format panel output, wherein we are using 210 mm wafer size for panel output of 600 watt peak and above. So there are 89 companies who have joined hands with us, and who are working together for this common goal to ensure, like, I mean, the overall integration, the overall system performance, everything is to the satisfaction of the customer. So of this 89 company, there are 5 companies who are into the production of wafer of 210. There are 42 companies who are into manufacturing of cell and modules, and in the downstream business there are 36 companies who are manufacturing inverters, combiner boxes, EPCs, mounting, cables and everything. And there are 6 companies who are already have developed capability to test such panels and to give necessary certifications which is needed. So more than certification, I mean, it is important that any new product, it has to pass the stringent test conditions which the panels might have to see in their 25-year of lifetime. So the certification agencies, I mean, it's very important for them to scale up and to be the part of this entire ecosystem for a sustainable growth. So this slide basically is the product offering that we have with our Vertex series 210. So we have product offering from 400 watt peak. The next product is 500, then 550, 600, and 670 is the latest product. And we have already supplied more than 20 gigawatt of this product in the global market till date. The silent feature of our 210 mm Vertex series is basically fourfold. So obviously the packing density, the shape of the cells we have changed. So instead of the one with a chamfered corner, so the 210 mm wafer, it comes with exact square shape. So we have better packing density, no empty spots in the panels, which improves your panel efficiency at a higher scale. And then we are using 12 bus bars, which are circular wires, which improve the overall performance of the cell, because the absorbance, the available area, the exposed area which is available for absorption of light. It is much higher, and then with these circular wires, we have a better absorption of the lights and everything. So that helps in further enhancing the panel performance. And beside this, the non-destructive cutting, which is a laser cutting technology that we are utilizing. So which gives better performance and better reliability of our cells. And then obviously the high density interconnection, which improves in the packing density, and a better efficiency conversion from cell level to panel level. So this is basically our mainstream product, which is 670 watt peak, which comes up with an efficiency of 21.6%. And all attributes, it's very clearly specified in this slide. And the key takeaway of this slide is the voltage characteristic. So in these panels, what we have designed, we have intentionally kept the voltage low and current high. So this way, I mean, the benefit which is getting passed on to the end customer is to utilize your string capacity at a much higher scale, which will help them reduce the BOS cost by maybe more than 7 and 8%, which comparison I'll have in the subsequent slides. So with this low voltage characteristic, you can connect as many as like 35 panels in the series, which will give like up to 20 kilowatt capacity in one single string. So you reduce significantly in your DC cable. At the same time, I mean, you don't have to, you reduce significantly in your workmanship as well, with higher panel output and less number of strings to handle. So this is basically a third-party study report, which has been done by Fraunhofer. So these are two case studies. On the left-hand side, you can see this is a study done on fixed tilt. So we have benchmarked a 540 watt peak panel, the standard one, the M10 182 wafer a panel, and we have done the study with fixed tilt. Like if we change the panel, keeping everything else same, if we change the panel from the standard M10 to G12, which is our product, 210 mm wafer 665, what is the saving? So you can very clearly see that the saving is as high as 7.42% in the capex cost, and in the LCOE you can save as much as 4% with the benchmark. And on the right hand side, you can see the same comparison with the bifacial 1P tracker. So you save as much as 5.46% with the benchmark with our 670 watt peak panel. And in the LCOE, you save as much as 2% in the cost of electricity. In this next slide here, so this is basically the breakdown. So you can see like at different component level, how much is the saving. So with panels, the large format panel wherein you have higher power from each panel, you save on the cost of panel, than the inverter optimization, civil engineering cost, electrical system, mounting structure, and DC cable. So all these component, you can see the breakdown. So from the overall saving, the significant saving is coming from the mounting installation, your electrical system, which includes your DC cable as well. So on the left hand side, you can see the comparison for the fixed tilt. On the right hand side, it is for 1P tracker. And one more thing, a key takeaway of this slide, which I think missed to capture in my previous slide. So, or maybe, yeah, I can cover it in the subsequent slide wherein I'll explain more about the packing thing. So, yeah, so let me move to, yeah. So this is another product. Other than panels, we have an offering of tracker as well. As I have explained that in the year 2018, we have acquired a tracker company. So we have introduced tracker in our portfolio. And Bangladesh market with high wind speed, there are few locations which might not be very suitable for trackers. But yet for other locations, even with the scarcity of land, trackers, they can help improve the LCOE significantly, because there is a common misconception that that with trackers you would need more land, but that's not a fact. I mean, in a limited space, if you use trackers, so you can reduce your DC capacity to achieve the same amount of electricity that you will be generating from a much bigger DC capacity with fixed tilt. So for example, I mean, if from a 1 megawatt setup, if I need 1.4 megawatt of DC capacity to generate say X amount of energy, with our trackers, with only 1.2 megawatt of DC capacity, we can generate the same. So though I mean, I would be I mean, if I do the calculation on DC capacity basis, so maybe the land area is more, but if we do the calculation from energy perspective, like I mean, for same amount of energy, what is the land needed? So in case of trackers, you can save significantly. So that is one aspect, that for land with trackers you can save. And then secondly, with trackers, I mean, if you have little bit additional land, then you can save significantly in your LCOE as well. I mean, if you can optimize your land little bit to fully utilize and unlock the benefit of the trackers, then the saving can be as high as 8% in your LCOE. And for other locations, we have extended our product of fixed tilt as well, which we are promoting in Bangladesh recently. So we have come up with fixed tilt product as well, in which we have offering of south facing as well as east west profile as well. So this product is something what we are promoting in locations where wind speed is as high as 260 kmph and above. So all such locations where tracker cannot sustain, we can very well provide our own trackers. And we have developed vendors and ecosystem for supply of raw material. And I mean, in very limited time period, we can deliver the products on site in Bangladesh from different locations. So piles, it can be coming from different locations. Maybe few component would be coming from China, and other component we have identified suppliers who could be supplying from different countries in Asia Pacific, so that we can optimize both in terms of cost as well as timelines. So this is a new offering that we have for Bangladesh, and we are hopeful that with this product we'll be able to help customers optimize the land and resources to generate maximum electricity possible from any resources. And obviously, for any product, the tracker or the panel, we have, I mean, our reliability, our quality control, stringent process, it's there as the baseline. And any product that we launch, it passes through more than 200 stringent test conditions at inception stage, as well as at the production stage, and even during the mass production. So every product qualifies those conditions, so that, I mean, you have a product which can run, which can generate for 25 years of its lifetime, be it tracker, be it fixed tilt, or be it our panel. So these two components are more critical, because that's something you put it for 20-25 years of generation. So we as Trina Solar, we offer as a most reputed and bankable brand with our balance sheet. I mean, we are there. We would be there for 25 years of the lifetime of the product, and we maintain all that quality, so that the the satisfaction of the end customer is always fulfilled. And this slide is basically just a perspective. So the black one here, which is mentioned as vertex, so that is basically our panel size. And there is a comparison. You can see the M10, which is 550 watt peak output panel. So you can see on a perspective level, on the appearance level, what is the dimension. And M1078, which is a 600 watt peak output. So so the dimensionally, it is a bit longer than Trina, but yes, I mean, maybe from width point of view, it's a bit shorter. So this is just to give you a perspective. In subsequent slide, you'll get a better perspective as well in terms of the dimension of the panel as well. So our panel, like, I mean, in order to ensure with the bigger format panel that it passes through different stringent mechanical condition, we do all sort of testing. So 5 enhanced testing, like non-uniform snow load, static loading, hail impact, dynamic load, wind tunnel test. So all these are the conditions which we put on our panels, and we test and we improvise our products so that they can sustain all such conditions on field. In terms of the performance for the static load, our 670 watt peak panel, they are tested for 540 Pascal positive pressure, the wind pressure of 540 Pascal, 5400 Pascal, and 2400 Pascal is the snow load which these panels can sustain. And for a tracker wherein you use 400 mm hole positions, so for such application, it can sustain wind load of 2400 Pascal and snow load of 2400 Pascal. So all our panel are tested, certified, and we are fully confident that on field they can very easily sustain such a stringent environment. So this is the health impact testing, though this is not so applicable for Bangladesh market, but yes, I mean, our panels are capable. We do testing much stringent than the guidelines set by IEC. So you can see the dimension of the Trina test healths are much bigger than the size of the of the one which is established by IEC. And we do more stringent testing in terms of the number of cycles, and our performance of the panels, even after the impact of hailstorm, it is almost negligible. I mean, the degradation is almost negligible. So you can see here in the table below, the degradation is less than 0.17%. So this is again the mechanical stability of the frames and all. So our panels, they are capable. We have tested it at much stringent parameters and conditions than what is set by IEC guidelines. And yes, this is something about the packing. So this new product comes with an entirely new philosophy of packing. So conventional packing is such in which the panels are stacked in a horizontal fashion. So in order to optimize the space and in order to ensure that the panels, it can sustain the in-transit shocks and everything, and to ensure that the minimum damage to the panels in its journey from the manufacturing to the site, we have developed a new stacking position in which we are placing panels in vertical. So you can see on the right hand side, this is basically the packing arrangement of our panel with this 670 watt peak panel. So this is basically how it will appear in a container. So in a container, we can house as much as 18 pallets of 670 watt peak, each with 31 pieces. So all together in one container, we can house as much as 370 to 380 kilowatt, which is roughly 12% more than the standard conventional packing. So in a conventional packing, in one container, you can get as much as 330 kilowatt. While with this unique packing that we have devised for this new product, we can get as much as 370 to 390 kilowatt of panels in one container. And with this current high sea freight, in which like from China to Bangladesh, Chittagong port, the freight could be as high as 8,000. It will play a significant role in saving your logistic cost by 10%, and in your overall project cost. Currently, the logistic cost plays a significant role. So this is something we have developed in order to reduce the cost of the project for the end customer and help them improve their levelized cost of electricity from solar. And these are few photographs of the project, which has been done with 670 watt peak panel. And you can in the photograph which is in the center, you can see the size of the panel. This is how it appears on site. And on the right hand side, you can see the stand which comes along with the packing. So this is something we are providing free of cost along with the panel, which you can utilize for unpacking and unloading the panels. So there is an entire philosophy. There is a training that we do on site as well as online, in which we help our customer to know how to handle these panels because of the large format. And we train them, we provide them with the necessary tools so that there is minimum damage on the panels on site. And this is basically the perspective, the size of the panel. And you can take a look on the left hand side how this strand which comes along with the panel is utilized for unloading and unpacking. So these are a few more photographs of these pallets and panels. So to give you a perspective, the dimension and the appearance. And yes, beside these panels, they are already compatible with all brands of inverters, and more than 200 inverters we already have certificates from them that our product is compatible. So the downstream integration, we have already worked out everything on that line as well. So there is no issue with compatibility with any inverters with this 660-70 watt peak panel output panels. Same goes for trackers. So fixed tilt, obviously, I mean, you can always optimize your design, but even trackers, all major trackers, they are compatible with our all three format, 550, 600 and 670 watt peak panel. They are all compatible with their both 1P and 2P trackers. And this is one ingenious tool that we have developed in which we can help our customers do the designing and optimizing the strings and everything for different types of inverters. So for any help, you can always get in touch with me or any of our sales representative who can help you in choosing your inverters and helping you in optimizing your design in terms of DC oversize, number of strings, number of panels in a string, and everything. So we have this tool through which we can help you optimize your plant design. So 25 gigawatt order already delivered, and more such we have in the pipeline, and we are delivering as we are speaking. So these are few photographs of the products, the projects which has been done with these panels, both on the rooftop and ground mount. So this is another project, 50.6 megawatt on floating solar with these panels. So I think this is the end of my slide. I think I've covered more or less everything which I wanted to present. So any query, if you have, you can let me know. You can ask me now or later as it's okay.
Okay. Thank you, Trinas. If anyone have questions, please use the Q&A box to put forward some questions to Mr. Trinas. Okay, now let's begin.